Hello and welcome all of you to Easy Electrical. So today we'll be recording another session of our it's a RRS, this is rapid revision series. And in the rapid revision series, what we basically do, we basically incorporate your classes, that is certain questions that are very much important for your SSC JEE and other related examinations. So before going further, so to give you a small idea about what all we do, we basically do a SSC JEE online course, and in that online course we basically provide you with the concept based classes for technical, for non-technical, test series, monthly tests are also included, practice papers every day will be given, and recording of the classes will be given via YouTube free of cost. And what we specialize in is that we basically do is this video recordings are made free of cost. Okay, so you once do your classes and it will be available with you for lifetime, because we believe in that once a student has studied from certain teacher, it is the responsibility of the teacher to provide him with all the guidance. We are not here to make huge amount of money. That is what I have observed in your YouTube, and in many of the cases they are charging huge amounts of money first of all, and they are just from the same student they are asking huge amounts of sums. So that will not be the case. If you do once, it will be will be with you for lifetime. So you can check all the concepts and revise everything as you wish. Other than that, we have also coming up with the practical lab sessions. It will be soon will be included. Practical labs means whatever labs you do in your colleges, that will be incorporated. And one more point is that exam specific notes. Suppose you are giving a certain examinations, and every examinations requires your what I can say is requires a specific type of preparations, and based on that syllabus we basically design certain set of questions that will be helpful for you for the last day of preparation. Okay, so for the last day of preparation is one such thing that we think is one of the most important parameters that most of us do not care, so we like to care about that also. Now today's topic is on diode, and today is the third class on the electronics part. Now here see, ripple factor of the full wave rectifier is, the ripple factor for full wave rectifier for full wave rectification is 1.21. okay, sorry, let me correct this. It is given at half wave rectifier, no, a full wave rectifier, no, the for full wave rectifier it is 0.48. See one thing, just by a simple understanding you can get. Suppose this is the waveform of the full wave rectifier output. Here you can see the ripple present means whatever the variations from a DC value. Suppose this is the DC value, and whatever the variation or changes is there. In case of, if you consider suppose say a single phase wave or a half wave rectifier, in that case you see the variation is much more. It is or not? So the ripple factor for a half wave will be much more, and that value is nothing but this one. And in the case of full wave rectifier, this is the value. This is the value. It can be calculated very easily. Okay. So whatever the AC component is present, IAC by IDC in presence of the DC value. Okay. Whatever the AC component is present in the total amount of DC. Okay. That means your rectification factor. Now coming to the next question. In case of full wave rectification, the output frequency is, we all know that it is 2 times. Okay. Suppose this is your input waveform. Okay. So if we call about frequency, what is frequency? This time period, this 1 by time period will give us what? 1 by t will give us what? This is time period. This 1 by t will give us what? Frequency. Now the same thing happens for your suppose if I do a rectification, if I do a rectification diagram, suppose here if I do a rectification diagram, here, then what will happen? Something like this will occur. So what we can observe from this figure? We can observe from this figure is that this time period has come up to be this time period. So in a single cycle here there are two cycles completed. In a single cycle of input there are 2 output cycles that are present. This is basically your input cycle, and this is basically your output cycle. So for the same time period, the input has single wave, the output has twice wave. So the frequency will be 2 times. Now coming to the next question. In Zener diode is operated in, see here, Zener diode is always operated in reverse bias. Okay, Zener diode is what we call it as a voltage regulator. Okay, so voltage regulator means whatever you have connected across a Zener diode, the same amount of the rating or the same amount of the voltage will be available across the load. Suppose, say I am drawing a simple figure. Suppose this is a source having a resistance. Now I have connected a Zener like this. See here, certain resistance I have connected. So whatever the voltage across this Zener is occurring or written, suppose a 50 volt or 60 volt, whatever it is written, this voltage will be fixed across this diode. You cannot change the voltage. The voltage will remain fixed across the load. Suppose this is the output voltage. This output voltage will always be fixed at 50 volt. Okay, so this is the most important factor because of which we basically use our Zener diode. Or similar questions I have also taken. So if I go with this question, see here, oh, similar question I have taken, 50 volts, 60 volts I have taken. So in this question you can see the question, it is saying that what is the maximum and what is the minimum Zener current. So maximum for say here, what is the minimum voltage range is 80 volt. For 80 volt if I calculate, here is how much it is, 60 volt, here it is 80 volt. So 80 minus your 60 divided by 5 kilo ohms, that means what it is, that is 20 by, that is 4 milliampere. So 4 milliamperes of current will flow through this if the voltage is 80 volts, right? In the out of the 4 milliampere, what will happen is, if you just divide this thing, that is 60 divided by 10, right? That is have I done some mistake? 60 volts are there. 60 volts, okay, 60 volt is there, and here is 10 kilo ohms, right? So if it is 10 kilo ohms, that means here 6 milliampere current will go in this direction. So in the reverse direction there will be a current flow, okay, and that reverse current will be how much it is, 2 milliampere. 2 milliampere of reverse current will flow like that. How it is coming out like this, 80 minus 60 divided by 5 kilo ohm will give us 20 by 5, that means 4, that means 4 milliampere. Here in this case 60 volts, V equals to I into R, V divided by R if we put that, in that case auto. So the current in this direction is in the reverse direction. If we take the 100 value, if we take 100, in that case 100 minus 60 divided by your 5 kilo ohm, that means 40 by, this is 8 milliamperes, right? So this current will remain the same. So if this current remains the same, in that case the current will be in this direction, and in this direction what amount of current will flow, 2 milliampere. So the maximum current that will flow for the 100 volt source, if I take for this problem, the maximum current will flow 2 milliampere, right, in this direction. But in the minimum Zener current that will flow, the minimum Zener current will be in opposite direction. Okay, so I think I have taken such a data. I must have taken certain data which is which will be less than this. Okay, so I just modulated the data sometimes. So okay, that is not an issue. So maximum 2 ampere current, 2 milliampere current will flow, and minimum current will not be this value. We need to change the value. Okay, the minimum current that is showing is upward direction. Upward direction the current will not flow. Okay, so minimum current from this observation, from this figure, we cannot draw, we cannot conclude. So we just need to mention one thing, that is the maximum current that will flow is 2 milliampere. Okay, so we cannot conclude that what amount of the minimum current will flow, because the current direction here is reversed. Okay, the opposite direction, but this opposite direction current will not flow. Okay, that is the issue. Now coming to next question, LED gives us light when it is forward biased. Okay, LED basically what it does is, whenever suppose we have an LED, we basically use gallium arsenide. Okay, in gallium arsenide what basically happens is, whenever you give a supply, okay, the electrons and the holes tend to move with each other. Holes will move in this direction and electrons will move in this direction. And there are also certain things that happen. There are some free electrons are also there. Basically free electrons contains large amount of energy. So a free electron, basically what it does is that free electron releases energy in the form of heat and light, right? And it is at a higher energy level. In that higher energy level, from that higher energy level, it comes down to your conduction, to your valence band holes, and combine with them. Okay, and because of that recombination, what happens is your heat and light is produced. Because of the recombination, what happens is heat and light is produced. The 2 points you need to keep in mind. First of all, whatever the free electrons are there, they are at a higher energy level. Whatever the holes are there, they are at a lower energy level. When electrons recombines with the holes, what happens is a greater amount of energy is released, and the energy after recombination that is released, which will be released in the form of light and heat, and that light is basically whatever light we see in case of an LED, right? Now coming to next question. The dark current is associated with, photodiode. Okay, a small amount of light has to be the light that falls on the photodiode basically works as a sensor, or it operates based on the whatever the light is falling on the diode. Now is below a certain value, the photodiode will not work. That is called as dark current. You just keep in mind that point, dark current, and you just go into the photodiode section, whatever books you have, and just read it through. You will have a greater idea, and I believe that some of the questions may be asked through this point as well. Now, which of the following diodes show a negative resistance between the two values of the forward voltage? Basically, your tunnel diode. Tunnel diode. Tunnel diode is such a diode where you can observe the two negative resistance characteristics, like this characteristics is shown. For certain values of the voltage, we can observe the common nature, that means a linear characteristics. But after a certain voltage, there is a decrement in the current. With increase in voltage, there is a decrement in the current. So there is a negative resistance region that can be observed in case of tunnel diode. Okay, and this happens because of that we obtain a valley point here. So a negative resistance characteristics in the forward voltage. Okay, this is basically your forward voltage across the diode, then this is basically your forward current across the diode. In the forward characteristics itself, we are observing one, your negative resistance characteristics. Okay, this is observed in tunnel diode. I think certain questions will be asked nowadays, because the level of questions is critical, going up, and such questions will be asked. A diode which is employed as a variable capacitor, we all know it is basically a varactor diode. Okay, so varactor diode is one such diode which is used as a variable capacitor. So none of this will be the answer. Now coming to today's next question, which of the following diodes has 4 layers? Basically Shockley diode has a 4 layer. That is PNPN diode. We can see here 4 layer PNPN diode is basically your Shockley diode. Okay, so coming to the last question for today, that which of the following diode has the highest concentration? Highest concentration of what? Highest concentration of doping concentration. Highest doping concentration is basically having your tunnel diode. Okay, in tunnel diode, doping concentration is doping concentration is more. Because of that thing, we can observe that characteristic like that I earlier had explained. And one of the important questions that I'd like to mention here, just write in the comment box, that is, which all diodes are basically operated in forward bias and which all diodes are basically operated in reverse bias. Likewise, what I have already said, that Zener diode is operated in reverse bias, right? Then photodiode is operated in reverse bias, right? So similarly, a tunnel diode is operated in which bias, varactor in which bias, Zener you know. So similarly, just make a list of all of the diodes, write diode name and their diode bias in the comment section. Okay, that's your homework for all of you, those of you who are watching. Now you all know, if you have any doubts, you can directly call me at this number, and you can directly mail us at this mail ID also. Okay, so what we are trying here is that we are trying to give you a structured course. In the structured course, we are trying to give you a thorough practice of everything. You know that the RRS is basically a very small valued course at rupees 10, and whatever courses we run, we will be trying to keep it as low as possible. Okay, so because in this medium only, you can see the quality, and whatever quantity and whatever quality we are providing you in just this value, only. And students, what I request is, do not follow YouTube in the case if you are not focused enough. Okay, because YouTube will spare you a lot of time. When there is a structured course, if somebody is providing a structured course, you can follow that. Otherwise, do not follow haphazard information. Haphazard information will not help you. If you follow a particular path, if you follow a particular direction, it will only help you. Otherwise, in any of the lectures, they are not giving enough information about the topic as well, and they are just selling the product itself. Okay, product selling is an important part of it, but the student must also be focused on whatever is taught in the class, okay, in the video. So thank you everyone for staying up to this point. Thank you and have a nice day. Thank you.